So good morning, students. Today we are going to discuss about quicksort. Okay. Already we have discussed in class about quicksort. So just I will refresh the points. So quicksort is one of the techniques under divide and conquer concept. What is divide and conquer concept means? We have one problem to solve. That problem can be divided into number of sub problems and the solution can be found for the sub problems, each and every sub problems, and finally we will conquer the solution into a single solution for a given problem. This is called divide and conquer technique, which is one of the important techniques in the design and analysis of algorithm concepts. Okay, so here what is the use of this quicksort means? Here they will give you one array of numbers. You have to solve it in either ascending order or descending order, depends upon the query. So when you are going to solve this in ascending order, we will take an example for ascending order. Here we will take one example. So here I have some values. I'll take some 1, 2, 3, 4, 5, 6, 7. One more will take 8. Will take 8 numbers they have given. For example, 2, 11, 4, 13. Here will take 12. 11, 4, 13, 3, 8. Nine, 50. So these are the numbers they have given for us and they asked us to solve in ascending order using quicksort. So what this quicksort will do means, first here in the process of quicksort, we will take any one of the first element. For example, this array starts from, anyway you know, index starts from 0, 1, 2, 3, 4, 5, 6 and 7. So here we have to take first element or last element or any random element as a pivot element. So here I will take our pivot element is 12. First element I am taking as a pivot element. Anything you can take. You can take 15 as a pivot element or randomly 13 as a pivot element or anything you can take as a pivot element. So what this process, after we will do the divide and if we'll apply the divide and conquer on this quicksort, what it will do means this 12 will be settled down in a proper position based on the ascending order in the array. For example, if you see 3, then 4, then 8, 9, then 11, then 12. So 1, 2, 3, 4, 5, 6. 6 means this fifth index. So sixth position, it will go and stand in the array. So, okay, what about the remaining things, ma'am? So if you keep this 12 here, whatever the elements which are in the left hand side of this pivot element will be the lesser elements of 12 and the right side will be the greater elements of 12. Maybe 13 and 15 will be in the right side, but 13 and 15 will be arranged in ascending order means we can't say. Like that here 3, 4, 8, 9, 11 like that it will be arranged means it is not possible. So that elements which are lesser than 12 will be placed, will be occupied any of the position in the left side of the 12 are like that. Greater elements will be occupied in any of the position of the right side of the 12. Okay, then again we have to take this left subarray and we have to solve with the same technique, and right subarray and we have to solve. Finally we can get the solution for the ascending order of the given array. This is called quick sort. Okay, so what here mainly we are doing partitioning. So here the concept is mainly partitioning. After the pivot will be settled down, after partitioning the pivot will be settled down in its proper position, and left elements are lesser than pivot element and greater right side elements are greater than pivot elements. Then again we have to do partitioning. We have to call recursively the partitioning function and we have to do the process, and finally we will get the solution. This is about quick sort and the divide and conquer technique. So now I will explain you with this example first, then I'll explain you with the logic. So first what we have done. So we will take first pivot element is 12. So what I'm going to take here is this first one I'm taking as a value, variable name is I. The last element I will take the variable name as j. Okay, either you can take lower bound, upper bound, anything. So first I will take here I, this is j. Okay, so if I is less than j, we can do one process. What we are going to do is first I'm going to compare. Ma'am, here you can get one doubt. Ma'am, if suppose 12 they have given it, suppose in that question they have given 12 twice, means where it will, that is depends upon either it can be in the left hand side of the 12 or right hand side, anything you can take, but here we will taking here only. So you can use, if you want to put it in the left hand side, sorry, that means this left hand side of the array means you can write it as less than or equal to. Right hand side means you can write it as greater than or equal to. Okay, anything you can use. So first what I'm going to compare, I'm going to take this array name is a, array name is a. So first what is your this one pivot equal to 12. So what I'm going to compare is if a of I is, so again, I'm telling you guys, if suppose your value, this is I is used to represent the index variable. So a of I means 12. If your a of I with respect to I, that element is greater than or equal to 12 means where it has to go? It has to go to right hand side of the pivot element after partitioning. So if suppose this is lesser than pivot element only, lesser than or equal to pivot element only means what you can say, it can be in the same position only, same position. That means this left hand side only, it has to be there. So no need to change. So just you can increment I only. Again, I'm telling you, you have to compare the pivot element with the array element with respect to I and j. I first we will take I with respect to a of I is lesser than or equal to pivot, lesser than or equal to, maybe 12 again they are given twice, lesser than or equal to pivot means just you have to increment I, you should not swap anything because it has to be in the left hand side of the pivot element after partitioning only. So that because after first partitioning, pivot element will be settled down in its proper position based on the ascending order. So the lesser elements or lesser or equal to elements should be in the left hand side only. So we are not going to change its position. We are not going to arrange it in the order also. Now our aim is to place the pivot element in its proper position. So I have to compare. How I can compare? A of I, otherwise capital A, anything you can take. A of I, 1 minute. A of I is less than or equal to your pivot. That means A of pivot. Pivot is what? 12. For your reference, I write 12 only. 12 pivot element. Okay. So what? If it is less than or equal to, means its position is this left hand side only. So I am not going to change. Just I will write I plus plus. Just I will write I plus plus. That's all I will do. So now you compare. This is first element, less than or equal to only. So what I have to do? I have to increment my I. I have to increment my I. Yes. Now again, A of 11. A of Y is what? 11. 11 is less than or equal to pivot. Yes. A is less than or equal to pivot only. So that again you have to increment I. No need to change. Again, same. 4 is less than or equal to 12. Yes. Less. So increment I. Now you see A of I is what? 13. 13 less than or equal to 12. No, false. So what you have to do, if suppose this one is true, you are going to increment I plus plus. Else, otherwise, what else? What simple logic I'm telling. Later I will explain the program completely. Here, this is snippet, so depends upon the procedure. So what you have to do means you can't increment I, so you have to decrement J. That means what? I have to check. So this is the value to go there. So I have to check this. So that what I have to do? I have to check the value of, I have to stop here and I have to check here what I had to check here. Else, what when I have to do this J minus minus, I have to check A of the condition is A of next I have to check A of J is what is the condition I told you already. If it is greater than only means it will be in the same area, that means right hand side of this only, otherwise it has to come this side. So A of J is greater than 12 because less than here I have given that equal, so just I'll use for greater than, means I have to do J minus minus. So how? Now it will check A of J is what? 15. 15 is greater than 12, so no need to change, so that J will be decremented. But 9 is what? Less than 12, so I can't do this. So both condition I can't do. What I have to do means I have to swap. I have to swap. What I have to swap means I have to swap A of I with code, you know. I will explain. Just to I'll write as a thing. A of I with A of J. I have to swap A of I with A of J. So that now this 13, I'll write here. 1, 2, 3, 4, 5. 6, 7, 8. So my 12 pivot will not change. 11, because till now we didn't find a proper position for pivot. So 4. Now 13 has to be swapped with 9. So 9 will come this side and 3 no change. 8 no change. 13 here and the next one is 15. I have swapped, but my I and J position is not changed. So where is my I? My I is in 9th, that means 4th position. and third index, and my j is here only. Then again I have to change. This is, I will put it in the loop only. Again I will change this. I will check a of I. Now current a of I is less than or equal to 12. Yes. So increment. Current a of I is less than or equal to 12. Yes. Increment. Current a of I is less than or equal to 12. Yes. Increment. But if you see here, Anna, so now if you see here, I and j in the same. So, but now I is what? A of I is greater than this your pivot element. So that what we have to do, we have to stop increasing I. Now I have to check with the j. A of j is greater than pivot or not? Yes, it is true. So I have to stop this. So what I have to do is, now I and j in the same position, I have to swap with respect to the value of this 12. So if I swap here, automatically here 12 will come here and 8 will go here. So that what it will, we will get 12 will be here, then 8 will go here and it will be settled down. So based on this, now if you see my 12 is here, the elements which are present left side the pivot element is lesser than pivot, and this side whatever is there greater than pivot element, but already it is arranged, so no problem. But this array is not arranged in ascending order, so again we have to do in partitioning. So I can take 8 is a pivot element, I can do like that. If I'll do recursively my partitioning function, if I'll call, I'll show in the program partitioning function, finally I will get my array in the ascending order. Okay, so now I'll close this and I will show you the so now you can see the program implement and analyze quicksort algorithm. So as usual, that header file we can add. Okay, so we have discussed so many times, always execution starts from the main method. Okay, so here I have taken the array, n is number of elements, low, high, and I am using. Okay, enter the number of elements and random numbers generated. That is already we have discussed. This is that you can give. So we will check low equal to 0. There we have taken ing here. They have taken lower bound, upper bound. I told here they have taken low. Low is 0. High equal to n minus 1. So first they are calling clock is a random. This one